Today we're going to be looking at making some synthetic polymers. And we'll start off by making polystyrene, which you might think of as styrofoam. In this case, it'll have a little bit different form because of how we're making it. When you want to make styrofoam, you have to use a different process. Same chemicals, but just certain ways that you have to form the polymer will make the insulating or the lighter form of it. Alright, so here we've got a test tube that's already been pre-measured for you that has 10 milligrams of benzoyl peroxide. That's an initiator, radical initiator. And to that, we're going to add 1 milliliter of styrene. This is a brand new bottle right here. And somebody had already opened it. So I'm just going to use the dropper to measure that. That in. Now we're going to want to do this in test tubes that we don't really care about because it's going to be difficult to get the polymer out when we're done. But you can just do this in the test tube that the benzoyl peroxide's been pre-measured in. After this, we're going to lower it into a sand bath, and we'll just barely have it in the sand bath. We don't want to heat it too strongly. And we don't want this capped too tightly either, because heating a capped container is a bad idea. So we'll just kind of set that on there. And this has to sit for 75 minutes. So we're going to do other polymers in the meantime. And we'll check back on this after we've done those other ones. But that's what it looks like in the sand bath. I had the thermal well set on about 3, and I've since reduced it down to 2.5 to try to keep this boiling down. And keep in mind that we do have the cork on there loosely so that it doesn't pop off under additional pressure from the heat. So we're going to check back on this one, and like I said, the reaction goes for 75 minutes. In the meantime, we're going to make some of the other polymers that go a lot faster. So now we're going to look at making some Nylon 6,6, and so to do that, we're going to add approximately 20 milliliters of adipilyl chloride in a carbon tetrachloride solution into a 50 milliliter beaker. And then we're going to slowly add 8 milliliters of hexamethylene diamine onto the top. And what should happen is a couple of layers will form, and we'll be able to pull out the nylon. And one of the fun things to do is to see how long of a string of the nylon you can make during this process. We can have a little competition. this. That looks not exactly like I expected. It's quite a mass there. But you can see how we're getting a string here, right? And sometimes I've been successful at dipping this string back in to lengthen it. Sometimes not, but there's... And this is going to be very tiny, so you have to be slow and delicate with it. Sometimes people will wind these around a glass stirring rod. Now it looks like I'm just holding this still, but it's already about half a meter long now. And I suppose this part of the lab might be skewed a little bit up. Dropped it. A little bit more towards taller people. But you just have to be very careful with it because it is very thin. So that's a little bit of nylon there. So the idea, again, is to pull it out of here very slowly. And it takes some practice to get this. And at a certain point, you're going to use up all of the reagents, and so you just have to, concede that we didn't make that long of a strand, perhaps. But that's how to make the nylon. So here's the best result that I was able to achieve, and you can see the strand right here, and I tried to get it laid out on the table fairly straight, and a little bit of it I was not able to untangle there, but it is just over half a meter. I have seen students in past years be able to make multiple meter long strings. They usually need to work together to help support the string because it's very delicate. But it is possible to get something that stretches most of the laboratory bench, which is 3 or 4 meters long. But you may have to try it a couple times. Now we're going to make an expanding foam, which is a polyurethane foam. And to these cups we've added about 10 milliliters of component A and about 10 milliliters of component B. And I might have these mixed up. Doesn't really matter. What we'll need to do is quickly pour one into the other and mix them with a little stirring rod here. And we're going to want to have some wax paper kind of laid out on the countertop because this does get a little messy. And you'll notice that I'm wearing gloves, and that's just because this stuff is so sticky and it can get on you and you'll have such a hard time getting it off. So that's why I'm just going to use the gloves just in case of that. So I'm just going to pour these together and then I'm going to mix them really well. And this process doesn't take very long. And you can actually shape this into other shapes. I'm not sure how well I will be at doing that. But once it starts polymerizing, you'll know. because it's going to start foaming up. So it's starting to rise a little bit right now. So I could try to make a little bit of a shape with this. I'm probably not the best at this. And this should harden in just a few minutes. So you don't have that much time to work with it. And we're doing this in these disposable cups because, again, very difficult to clean out. Now, another thing that people will do is just let it sit inside the cup, and then it can kind of mushroom out the top. And that's kind of a fun experience. And the shape that I poured on here ended up not working out the way that I thought it would, but now I just have to wait for it to harden up. So I'll check back in when this is actually hardened up. So this is the result of the expanding foam. Some of it's still a little sticky up here, but that will set with time. And you can notice that we took roughly about 20 milliliters of material and had it expand quite a bit. Now, you can do more things with the expanding foam. So there's some other options that have been done here. And I've also noticed people that will just leave it in the cup and then watch the cup expand over and kind of mushroom out. And that can be a neat effect. Another thing that is possible to do that we didn't do today is if you add a little bit of food coloring to one of the reagents, you can dye the foam just a little bit of a different color, and we'll have that available for you to play around with. Next, we're going to make a maleic anhydride styrene copolymer. To do this, we'll need some maleic anhydride. It's 0.35 grams. And then we're going to add half a milliliter of styrene. We'll add 5 milliliters of toluene, and after we've added all of those and got them dissolved, we'll go ahead and add the radical initiator, which is 50 milligrams of the benzoyl peroxide. So I'm going to go ahead and add in some of this toluene next, just to get things dissolved. About 5 minutes. got pre-weighed amounts of the radical initiator. So I'm going to go ahead and dump that in. And then we're just going to want to warm this up a little bit on a heating wheel. So I'm going to move that back over to our other fume hood where our other polymer should be about done by now. So I'm just going to warm this up a little on here. Might take this out. Let's see. And you'll notice that this is very viscous now. And it's because it's almost completely polymerized. So I just want to warm this a little bit, so that's why I'm kind of keeping an eye on it. Alright, so it's been 15 minutes of heating on the thermal well. And I've cooled this down at least to room temperature. We're going to add 3 milliliters of methanol to this. And we're going to cool it down on ice after we kind of stir this up and break it up a little bit. And then you can also see there's a test tube that's laying next to it. This is what we started off with first. This is the polystyrene, and we've made a solid polymer at the bottom here. I can show you that with these tweezers here. So we've turned a liquid into a solid, and again, this polymer is the same kind of polymer that you would get in like a styrofoam cooler or something. This has just been processed a little differently to make the cooler. Alright, so we're going to mix this around a little bit here. I'm going to cool this, and we'll be able to break this up. This is the copolymer, the maleic anhydride styrene. So after we cooled down the copolymer, we scraped it out to break up the chunks, added some methanol to the solution, and then we filtered it on a Buchner funnel to isolate the copolymer. And it's kind of this fluffy, almost like snowflakey looking material here. And you might want to try to use a rubber policeman or a glass stirring rod to try to get the rest of this out and clean up your flask. And so we've made several polymers today, and hopefully this lab was largely fun to do.